Okay, today we are expanding and condensing logarithms. We use this, the purpose for this is when we actually go to solving exponential and logarithmic equations. That's why it's used. So, we first use our properties, and our properties are very similar to the exponent properties. When we have a logarithm of base b and we have mn, we have these two, this is called the product property, these two are multiplied, then we can expand that to be log base bm plus log base bn, kind of like when you're adding exponents, like when you're multiplying with exponents, then you add them together. So it's the same sort of thing with logarithms, it just ties it all together. Same thing here when we're dividing and we have log base b of m over n, then we subtract log base b of m minus log base b of n. So it's the same concept. Now, something that's a little bit different, when I have a logarithm of base m raised to the power of n, when I'm expanding that, then I'm bringing that power, that exponent, out to the front. And it's n log base b of m. Now, a lot of this will make a little more sense with an example, so here we go. All right, if you see this logarithm and they tell you to expand it, I'm going to erase this so you can see it without all that there. When they tell you to expand it, you are writing it in this format, and I'm just going to write one of these up. If you have an exponent, like this one does, there's an exponent here. The exponent goes out front, then the log, then the base. So the exponent, which is 2 right here, then the log, then the base of 7, and then I've got x. So for that term, I'm writing it exponent log base term. Now for the term, that's either going to be a number or a variable. It's never both. So it'll either be a number or a variable. Here, since both of these are variables, you're going to be using variables. Now, because x squared and y are being multiplied right here, you use the product property, which says, okay, when they're multiplied, we use an addition symbol. So you write plus, and then you do the same thing, log base 7 of y, but the y doesn't have an exponent, so there's no number there. So it's log base number or variable, exponent log base number or variable. That's how it goes. So if I were to do this one right here, log base 2 of 3 x squared, I'm going to write log base 2 of 3. 3 does not have an exponent. Plus, because this is multiplication, 2 log base 2 of x. And that's how you would do that one. Okay. Here's another one. This one has division. You see this division symbol here. So I'm separating the terms. I'm going to do log base 2 of x squared and log base 2 of 4. I'm going to do both of those. Since the x has an exponent, I'm putting my exponent here. Exponent log base 2 of x. And since it's division, instead of a plus sign, we're writing a minus sign. And I write log base 2 of 4. Let's do this one. If you remember how algebra 2 is always wrapping back to prior knowledge. So this is a cubic. This is the cube root of x. And remember, you learned way back in first semester that the cube root of x is also x to the 1/3 power. So in all honesty, this one can be rewritten as log base 5 of x to the 1/3 power. So when I expand it out, again, exponent log base number or variable. So that 1/3 comes first, then log base 5 of x. And that's how that is done. Okay, condense. We're going to go backwards now, and we're going to condense these. So you see all these plus signs. That means that I have nothing but multiplication going on. So I am doing log base 3. They're all log base 3. And then I'm taking these numbers, 4 times 2 times 2, and multiplying them, and that gives me 16. So this is this when it's condensed. All right? This one, same thing, except for now I don't have log. I have natural log. It's just another logarithm. Natural log is a log to the base of e, and e is an irrational number of 2.7 13, blah, 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 blah. Kind of like pi is 3.14159. E is 2.7, and I don't remember the other digits, but you can put it in your calculator and see. Anyway, same thing. This is a natural logarithm, so instead of writing log something, I'm going to write natural log, and then x is raised to the second power. That's here. The other plus sign is right here with the 6, so x squared times 6, and then this part, because it's a minus sign, goes in the denominator. So it is natural log 6x squared over 3. Now, because I can simplify that, I do. So natural log of 2x squared. All right, again, let's do this one. And again, remember, if it's positive, it's in the numerator. If it's negative, it's in the denominator. So this is positive. These two are negative. They're in the denominator, so I'm writing natural log. And then I've got x minus 3, which is my term, raised to the second power. And then these go down here. So 6, and then x plus 2 raised to the third power. I know it's a lot to take in, but there we are. Thank you.